So today's topic is based on the data transfer techniques. So methods of data transfer. So data transfer mechanisms, basically it is essential in any microprocessor based system, and it can take place between the microprocessor and the memory and the processor, and as well as with the input output devices also, or the memory and an input output device. Okay, so either it may be happened between the processor and the memory, or it can be happened to the processor and input output devices, or memory with the memory and input output devices. So data that can be transferred in several ways. Now the mechanism differs based on the characteristics such as addressing of the device and amount of data transferred, method of data transfer, and the interaction among the devices. Now here the data transfer mechanism is divided into certain categories. So these are given over there. Based on the addressing of the device, it is divided into two methods. One is the IO mapped IO access and memory mapped IO access. As I have told you earlier classes, that uh, you can you can interface the IO devices with the microprocessor using two techniques: IO mapped IO and memory mapped IO. Okay. Uh, the second is the based on the program and hardware involved, where program data transfer is also available and direct memory access method is also available. So under program data transfer technique, there are two types of method which are used to transfer the data, that is poll mode of data transfer and interrupt driven data transfer. And under direct memory access, or DMA, in short it is called DMA, uh, there are two modes. These are burst mode and cycle steal mode. Now third category, which is based on the way how the based on the method of data transfer and the access. So there are two ways. One is the parallel data transfer, and another is the serial data transfer. Under parallel data transfer, there are two techniques: simple data transfer technique and handshake mode of data transfer technique. And under serial data transfer technique, there are two modes: synchronous data transfer and asynchronous data transfer. So I will discuss one by one in short. The first one, which is the IO mapped IO and memory mapped IO access data transfer. So in IO mapped IO, the device and the IO device and the memory are handled separately. A separate address range is assigned for input output devices. Separate control signals are used for memory access and for IO device read write operation. Now, the microprocessor has separate instructions for input and output device access, such as input in instruction and out instruction of the 8085. So, as memory and IO device accesses are governed by separate control signals, a single address that can be assigned to both an IO device and a memory location. But in case of so that is happened in IO mapped. In memory mapped IO technique, what is to be done, that is each input output device is treated like a memory location, where the same control signals are used for IO device read write operation and for memory access operation. And here each input and output device is identified by unique address in the memory address range. So all the memory related instructions that are used to read data from memory are used to access input and output devices. And for example, STA related instruction, LDA related instructions, M related instruction like move A comma M, move B comma M, M comma M, B comma M, C comma M, M comma B, M comma C. So these are, now since the IO devices are some of the memory address space, the maximum memory addressing capacity is reduced in this system. Okay, so um, preferably IO mapped IO technique is used compared to the memory mapped IO technique. The next is the second category based on the program and hardware involved, where the program data transfer technique can be used. Uh, Here, the instructions for program data transfer, these are written and controlled by the programmer and executed by the processor. Now, the data transfer between the processor and IO devices, or just opposite to this one, IO device to the uh, processor, these are so these takes place by executing the corresponding instructions one by one, sequential instructions. And, this so this is basically identical to read and write operations for mnemonics and device registers. So an example of programmed IO is a device driver writing one data byte at a time directly into the device's memory. Okay, so this type of data transfer that can take place at a time that is determined by the programmer, and based on the time of execution of the data transfer instruction, program data transfer is divided into further two modes, that is pole mode of data transfer and interrupt driven data transfer. Now in pole mode of data transfer, what happened, the data is read from an input device when the processor or the CPU which is ready. Now the processor then executes the data transfer instruction, and if the input device is not ready, the processor waits until the device is ready with data. Similarly, data is written into an output device by the processor when it executes the write instructions corresponding to the output device. Okay, so here the program is written in such way that the processor waits in a loop until the output device is ready to receive the data. And clearly, in waiting for the device to be ready, processor time is wasted in this mode of data transfer. Okay, next, which is the interrupt driven data transfer. Here the data is read from the input device only when it is ready with the data. So when the device is ready, it gives an interrupt signal to the processor indicating that the data is ready. And in the ISR, the program is executed to read the data from the corresponding input device, and similarly the output device gives an interrupt to the processor when it can accept data. Now the programmers have to write an ISR, means interrupt service routine, for that particular data transfer to the corresponding output device. Okay, so this interrupt driven data transfer is very advantageous, as data transfer is done only when the device is ready. The processor need not wait until the device is ready. Okay, so here the processor can execute some other main routine and data transfer program that will be executed as different ISR. It is an efficient technique because processor time is not wasted in waiting while the IO device is getting ready or not ready. So slow IO devices that can be interface for data transfer using this interrupt driven technique that can be very useful. Okay. Next is the DMA, or it's called the direct memory access. Have you heard about this DMA, direct memory access? Anyone? Have you heard about this technique, direct memory access? Have you any idea
Yes.
what is that? Can you tell me? Can you remember it? Okay, so direct memory. Now one thing, that is in programmed data transfer, the processor is actively involved in the entire data transfer process. So uh, the data transfer rate is very limited. Now the processor is tied up and processor time is wasted. Now to overcome this problem, the direct memory access method of data transfer is used. Okay, so in this technique, what happened, the the peripheral IO device and the memory, without the intervention of the processor, the required number of data can be transferred. Okay, now the basic idea is to transfer uh, blocks of data directly between the memory and the peripherals. Okay, large number of data can be transferred easily using this technique. Even though the transfer is done without the processor initiates the DMA operation. Okay, and this technique is generally used to transfer large blocks of data between memory and the mm, input output device. Okay, now during DMA data transfer, uh, what what is what happened that processor or the CPU that is kept in an idle uh, mode or suspended state, that is called as hold state. Okay, so DMA performs high speed of data transfer to and from mass storage peripheral devices such as hard disk drives, magnetic tapes, CD-ROMs, and video controllers. So everything. Okay, so at hard disks that may have a transfer rate of 5 Mbps, that is 1 byte every uh, 200 nanosecond. Okay, so performing such data transfer using the CPU is not only undesirable but also unnecessary, since the CPU transfer rate is limited by the speed of the memory and the peripheral devices. Now, under normal circumstances, the CPU has full control of the address and the data bus in the system. So when this direct memory access occurs, an external device or DMA controller takes over the temporary control of the system bus from the CPU, and CPU writes necessary control words into the DMA controller to indicate that the mm, read or write operation or device address transfer, or the starting address, what is really the starting address, or the amount of data, how much data will be transferred, everything will be given. Okay, so after this type of initialization, the DMA controller takes care of the data transfer and hold request that in 8085 in the processor there are two pins which is called the hold, HOLD, and HLDA. Okay, so this hold, HOLD, as you can remember, there was two pins in pin diagram, hold and HLDA. So this hold, actually hold request that is received, and hold acknowledge that is given from the 85 to that corresponding device which is requesting to serve. Now now what is to be going on when this hold signal is received and HLDA, hold acknowledge, is to be given? Now the peripheral or the DMA controller, it asserts one of the request pins such as hold for holding the processor. Now the processor completes its current instruction execution and enters into the hold state. Now in the hold state, the processor temporarily stops the execution of the instruction and releases the address and data buses by making them enter into a high impedance state. Now the processor issues a hold acknowledge signal to indicate the release of bus control to the peripheral or the DMA controller. Now the operation starts. So when it is completed, the peripheral or the DMA controller removes the whole signal applied to the processor and relinquishes the bus control. Okay. So in general, a DMA controller can interface several peripherals that may request DMA with the processor. Okay. It is the uh, controller that decides the priority of the DMA requests that are received simultaneously from many peripherals. Okay, and it then communicates with the peripheral devices and the processor and provides memory addresses for transferring the data. Now normally one IC has to be used to perform this type of data transfer. Specific or dedicated IC is there, which is called 8237 IC, which is programmable DMA controller. Okay, so it's a peripheral IC which can be programmed according to your requirement based on the DMA operation. So that's why it is called programmable DMA controller, which is 8237. The IC number is 8237, and it is called as programmable DMA controller. So that is the controller device which is most commonly used with the 8085 or any processor. So it is a four channel device with each channel is capable of addressing 64 kilobytes of memory. Okay, and each channel being dedicated to a particular peripheral device is also. Okay, so this 8237 IC, in this IC, in this DMA controller, so this can be used to perform the DMA data transfer using two methods, either burst mode or cycle stealing mode. So burst mode is also called block transfer mode, and cycle stealing mode is also called interleaved mode. Okay, so don't confused with these two terms. Burst mode can be written as block transfer mode, and cycle stealing mode can be written as interleaved mode. Now, in burst mode, what happened? A complete block of data is to be transferred in a single DMA cycle. Okay, and the system bus is released by the peripheral or DMA controller only after the required uh, bytes of data are transferred. Now, in second method, which is called the cycle stealing mode, uh, this one, the cycle stealing uh, mode of data transfer, a uh, block of data which is to be transferred over many DMA cycles. Okay, and the system bus is released to the processor after a byte or a set of bytes are transferred in one DMA cycle, and that's why the processor is not suspended from its activities for a long time. It takes several DMA cycles to complete the transfer of one block of data. So these are two modes under the DMA process. Now the third category, which is based on the data transfer, how data is transferred and accessed, the method, which is the first one, is a parallel data transfer technique. So in parallel mode of data transfer, all the data bits in a word that are simultaneously transmitted one by one. Now all of you know that 8085 has it's an 8-bit processor. 8 bits word is there, so all the 8 bits are transmitted and received in parallel form. So in some special cases, the number of data bits that can be transferred with a lesser than 8. In general, that is the parallel data transfer, which is used for uh, transfer of data over short distances, such as within the system or within a PCB. And it can be done either in poll mode or in interrupt dependent mode, as I have discussed earlier. So in poll mode, data is read from the input device by the processor at a time determined by the processor, and this poll mode of data transfer that can be done in two ways: synchronous or simple IO and handshake IO. Okay, so simple IO or handshake. So in simple or synchronous modes of data, uh, so it's better to consider it's a simple uh, data transfer technique where the data is read from the input device by the processor irrespective of the status of the input device. Now it is assumed that the input device is in synchronous mode with the processor, and that it is ready with the data whenever the processor reads the data. Okay, similarly, the data is written into the output device irrespective of its status. Now the processor assumes that the output device is in synchronous mode with the processor. But in case of handshake mode of data transfer, the processor checks for the status of the IO devices before any data transfer technique, and an input device gives a signal to the processor indicating that it is ready with the data. So then the processor checks continuously for the reception of this signal, and upon reception can read the data. Similarly, an output device gives a signal to the processor indicating that it can accept data. Now, the processor, before writing data to the output device, checks for this signal. And if this signal indicating readiness of the output device which is available, the processor can write the data to the output device. And the signals that are transferred between the devices and the processor are called handshake signals. Handshake signals. Next method, which is the serial data transfer method, where there are two techniques. Now, before going to discuss these two techniques, I would like to share something, that is parallel data transfer. It has some drawback. And what is the drawback? So it needs several words to transfer all the bits of data, so it cannot be used effectively for long distance data transfer purpose. So as one word is used for each bit, byte wise data transfer are 8 times more expensive than a single bit transfer. So serial data transfer is the solution for 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 data transfer over long distances. Okay, it's a low cost way to send data over long distances. And in serial data transfer technique, only one bit is to be transferred over a data transfer line, and all the bits in a data word that can be transmitted by using a shift register and transferring the data bit by bit. Okay, so parallel to serial data conversion, that is to be done by a device called universal asynchronous receiver transmitters, or in short it is called the UART. So this is very useful to perform this. It is needed to perform the serial data transfer. Now in serial data transfer, uh, first a few things you have to remember. These are most important. The first is the speed or the frequency at which the bits are transmitted into the serial data line. Uh, Second is the frequency at which the data is transmitted serially, that is technically called the baud rate. And baud rate is the measure of the number of bits transmitted over a second. Okay. Next is the um, mode of data transfer. So there are two modes of data transfer: synchronous and asynchronous. And next is the voltage level for logic 1 and logic 0 for the data being transmitted. So various serial communication protocol defines these aspects and as standards for proper communication. So in synchronized or synchronous data transfer, the device that sends the data and the device that receives the data both are synchronized with the common clock signal. Now in this mode, a fixed and a known time frame is there. But in case of asynchronous data transfer, data words are transmitted with a random time frame between them. And in case of most microprocessors and any computer related data communications, these are based on the asynchronous mode of transmission. Now microprocessor use these interprets and use different interrupts to and other software techniques to synchronize randomly this timing between the data words so as to receive the data completely. Now in this type of technique, the modem plays an important role in serial transmission. It is a modem. What is modem? So it is a device that allows transmission of serial data over communication lines such as telephone lines. Okay, so in general, communication lines, these are capable of carrying the voltage changes required for a direct digital connection. Now, a modem that overcomes this limitation by modulating digital information into analog signals using one of the modulation techniques and demodulation it back into the digital information upon reception. Now, uh, so the computer or a microprocessor terminal that initiates this serial communication is called the data terminal equipment. Data terminal equipment. Okay, and the final equipment that receives the serial data is also called the data terminal equipment for communication purpose. Okay, so data communication equipment is another device which is to be used that connects the data terminal equipment to a transmission line. So a modem, uh, so in actually transmitting data terminal equipment which sends the serial data to the data communication equipment, and this data communication equipment is generally uh, a modem, because this helps in level shifting and transmitting the serial data over the chosen transmission line. And so different standards will be maintained like IEEE 488 standards, like it's not in syllabus. So that's all. So these are the different techniques which can be performed using either these any one of these method, okay, as per the requirement.